diving in? Sorry, Chris. That was not a personal comment. If it makes you feel better, Chris, a couple days ago they locked me out too. So. You know what I hate the most? I'm doing this more and more. I hate walking in the wrong classroom. So you guys, let me come back. I'm running out of room. You guys, would you mind if I erased the middle board? Anybody have any questions before I get rid of it? So you guys, check this stuff out. If I choose one of my values of the solutions to the indicial equation, right? Should I spell that? Indicial equation.
Indicial?
Indicial.
What does that mean?
Like pertaining to the index?
Yeah.
Okay.
So if I take one of the solutions by indicial equation, like for example, r being equal to 0. I think
Yes.
if r is equal to 0, simply diving in here and rewriting this recurrence relation, I think my recurrence, bless you, relation becomes this. Actually, I'm too far away. You tell me what it is. A sub k plus 1 is equal to, is it negative 1 over 2k?
2k plus 1.
Plus 1 times a sub k.
Yeah.
All right, you guys, let's run through the k values. If k is equal to 0, I see that a sub 1 is equal to negative a sub naught. If k is equal to 1, I see a sub 2 is equal to negative 1 over 3 times a sub 1, which is the same thing as positive 1 over 3 times a sub naught. But again, listen to what I'm saying. Don't look what I write. I maintain a sub 3 is obtained by allowing k to be 2, but that just simply gives me a negative 1 over 5 times a sub 2. That's the same thing as a negative 1 over 5 times 3 times a sub naught. And likewise, a sub 4 is merely going to be a negative 1 over 7 times a sub 3, or shall I say positive 1 over 7 times 5 times 3 times a sub naught. Let's see if you guys can find the pattern. I haven't. Would that be an a sub n? Equals something in terms of a sub naughts. I'm going to have a factor of negative 1 to the n, I think. Let me see, if n is equal to 1, it's negative, yeah, I guess I got my n straight now. My question is this, what the heck is downstairs?
2n minus 1.
I agree with that. In stereo, it's 2n minus 1. Everybody happy? Everybody happy? Everybody exhilarated?
No.
No, I'm not either. I think my denominator really has a leading factor of 2n minus 1. I think the next one is 2n minus 3. All the way down to a 7 times 5 times 3, maybe even 1. Do you guys agree?
Not if you like product notation.
Not if you like product notation. And you guys, let me check something. I'm kind of nervous. I really am. Can I check my a sub naught? All right, if I plug 0 for n here, don't look at the rest. If I plug 0 for n, what should be on the right-hand side of the equal sign?
Not 0. Negative.
Yeah, not 0, but I think it should be specifically a sub naught. Let's see if it is. The highest factor when I plug 0 for n is going to be negative 1. Plugging 0 for n is going to be positive 1. Isn't it going to be a negative a sub naught? Wow, it doesn't work. Shoot. See what happens when I plug 2 in or 1 in for n. Plug 1 in for n, it's negative. Well, okay, should be. 1 in for n gives you the highest factor, which is positive 1, times a sub 1. It works. So you keep in mind when I write my solution, this recurrence relation does not work when n is equal to 0. It fails. So when I write my final solution, I think that means I'm going to take off here for the first one term over there with those sums.
Well, it doesn't work because we don't have the prior, right? We don't have the a sub negative 1 implied, so it has to work anyway.
Well, that's okay. Technically speaking, it's no longer a recurrence relation. This is not an a sub n minus 1, is it? It's fixed at a sub naught. I'm just saying, if I plug 0 for n here, I get an a sub naught on the left-hand side. I better get an a sub naught on the right-hand side, and I don't. And so I think for the very first term, when I write my final solution, I better shave off the very first term.
If it fails at n equals 0 for this specific additional equation, or or I guess the specific value of R, does that say anything about the other value
No.
of R?
No, not necessarily. If you guys are okay with my pattern, let's jump to the next one. I'm sorry, Michael, go ahead.
Okay, so for this one, so when we're initially setting up A thing in, and then we're figuring out the pattern, writing it down roughly, we check it by plugging in n equals 0 and trying to see if we get that, but we know, or at least in most cases, we shouldn't be able to get our first.
How about saying this? You place faith that you do get it.
Okay,
And if you don't get it, run and hide.
right.
And do something else to panic.
And-
But I'm serious, Michael, check this out. The way you started your sentence was perfect. If I plug 0 for n on the
During
left-hand
the next
side, I get
test,
a sub
everybody's
naught. Let's
gonna
just see
run
if I
out.
get a
It's
sub
fine.
naught on the right-hand side. My largest factor is -1. Underneath the positive one,
Just get
that
up
means
at
a
your
sub naught is
desk.
negative a sub naught.
Cower,
That's a problem.
weep.
That means when I come up with my series representation for this solution, I better shave off the first term. Sometimes I'll just shove more than one of the first terms, more maybe the first two, but I check the second term, it seems to fit the pattern.
Okay, and so the ones that don't fit the pattern, just erase.
Yeah, or in the sense, well, I shouldn't say erase, we're just gonna have to separate the term in the end. It's not gonna disappear magically.
Okay.
Something else. There was something else, I just lost it. Oh, I didn't tell you this, but I set this problem up in such a way that I at least went this far. That when it comes to the solutions to the initial equation, they don't differ by an integer. Don't worry about it right now, but I note that those two values do not differ by an integer. If they did, I think I'd be in big trouble. I think the recurrence relations I generate will just duplicate each other. So next,
Wait, whoa, I'm trying to parse that.
I'm saying this, if these two roots to my initial equation differ by some integer, I think what's gonna end up happening is this recurrence relation is gonna cycle upon itself. I don't think I'll get two independent solutions in the end.
But R has nothing to do with K. So how would it switch on us?
I think it's intimately related, because I think it'll change, think about it, if R is equal to 1, is this denominator just 2k plus 1, as opposed to 2k, which I had before? I think I can potentially cycle the same values over and over again.
Okay.
I think in this particular case it doesn't happen, because I think if I check out what happens with that recurrence relation when I choose the other solution of my additional equation, that is R is equal to 1/2, I think my a sub k plus 1 becomes a -1 over something times a sub k. Okay, I'll slow down. Picking the 1/2 up off the board, slapping for R here, does that give me a 2k plus 1?
No.
Never
2k plus 2.
Isn't that what he just said?
Oh, you said 2k plus 1.
I
and
meant
then
when it said it.
you wrote k plus 1 in parentheses. All right, I see
2k
it.
plus 1.
All right.
You guys, let's run with this. A sub 1 is generated by plugging 0 in for k, and I think that just simply gives me a -1 over 2 times a sub naught. A sub 2 is generated by plugging 1 in for k. I think it gives me a -1 over 2 times, sorry, so slow, 2 times a sub 1. Can I just get rid of the black stuff? That came from the work in the middle board anyways, right?
Yeah.
Oh no, I want this terms of a sub naught. I better back substitute. Is that a +1 over 2 times self thrice times a sub naught? I think a sub 3 is generated by replacing k with 2. That gives me a -1 over 2 times 3 times a sub 2, but that's -1 over
2 to the force.
2 times self the 4 times? Times 3. You can see a pattern.
No.
Let's do another one. So a sub 4 is equal to -1 over, well, a sub 4 is generated and k is equal to 3. Is that going to be 2 times 4? A sub 3, which is +1 over 2 times itself, 4 times up here, but 3 times down there, times a factor 3.
Fibonacci numbers, obviously.
Fibonacci?
I think really depressed if Fibonacci numbers end up in the solution.
Why would you be depressed?
Hard
said he
modeling it.
I think it might be easier if we, instead of writing 4 as 2 times 2, write it as 4.
Yeah, you see it already, don't you? Let me choose color pens. How about red? Is that a 4 times 3 times 2?
Yes, so,
Is that a 3 times 2?
yes.
Is that a 2? But here's a 1. I think I see factorials. And I think with everything else, I see 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st. That's not looking bad.
That's not that bad.
Yeah, so you guys see it?
So it should be,
Let's write it out. I think that suggests that a sub n is equal to -1 to the nth power. Do I have that correct so far? I really don't know.
yeah.
Yeah, it should be negative if n is equal to 1. I think downstairs, however, I've got 2 to straight for
2 to the n?
power.
Yeah.
Times,
N minus 1 factorial.
oh, was it n minus 1? I thought it was n factorial.
No,
N plus
it's
1.
Oh, we did have 4. Yeah, so it's N factorial.
Okay, so we
It's
start-
Yeah, it's n factorial.
That's the even factorial function.
Yeah, yeah,
N is 1.
that's it. Yeah. Well, times
Oh,
a
I
sub
missed
0.
something. Hold on,
Yeah.
I missed.
No, he was saying that's one n factorial, one, right?
I was
Yes,
looking
it
at
is.
2 in the first one, so.
Oh no, you guys can't do this. Shoot, they both involve ace of knots. So I got an idea. At this stage of the game, let ace of knot be equal to 1. That being the case,
So can you just let a sub naught be equal to anything? You just chose one?
you know, good point. You can let ace of knot be any real number you darn well please, non-zero, but in the end, it's going to be absorbed in C1s and C2s.
Okay, so
That's why I'm lazy.
one's just the most strategic way to go.
Yeah, but if you want to choose to be phi, go for it. Just do it.
Okay.
By the way, you guys, I still didn't check something. I forgot to check to see if it works when n is equal to 0. If n is equal to 0, what's 2 to the 0 power?
1.
What's it 0 factorial?
1,
What's -1 to 0 power?
-1, or 1, 1.
Oh, so I guess ace of knot's equal to ace of knot. I guess the pattern works
Okay.
when n is equal to 0. But it didn't over there. So, I think to come up with 2 literally independent solutions, you guys help me with this. Do you agree with the following? Whoa, wasn't that my first step? I made the supposition as a solution to this form. Isn't it the same thing as this? And so I think my first solution is going to be x to the r power. Well, with my first one, my r value was
0.
just 0. Times, you guys seem to agree with me that I have to shave off the first term. And I think shaving off my first term, isn't that just simply going to be is that going to be a positive 1? Plus the sum, as n ranges from 1 on up, of my a sub n, which is this. It's been too long. Instead of 2n minus 1, 2n minus 3, all the way down to 7 times 5 times 3, times x to the kth power, or excuse me, x to the nth power. I misspoke. I think my y sub 2 is going to be nothing more than x to the r, which is x to the 1/2, times the sum of my a sub n. Times my x to the nth power. Daniel, sorry.
Why did we replace a naught with 1 again? So I know you wrote it over there, but is that from something?
For this simple reason, I was really being this lazy. I was just saying, notice how n is equal to 0. What I get on the left-hand side is. But that means when I plug 0 for n on the right-hand side, I better get an ace of naught. Because on the left-hand side, I got an ace of naught. It's just that with this pattern, notice that the largest factor is, when I plug 0 for n, is -1.
Yeah, I'm just wondering, shouldn't it just stay as a naught instead of being replaced with 1? Like, why did we make that assumption that a naught has to?
take it back. I don't mind if you keep it as an ace of naught, as long as in the end you combine these two by looking at C1 times 1 plus C2 times the other, so that the ace of naught gets absorbed. That would be fine. I got rid of it initially because it makes me nervous. Because if I take it last time, remember I got like an ace of naught here and ace of 10 there. They act with my C1, C2.
So,
But now that they're the same, I need to just make sure you don't see it. Or if you do see it, that's fine, keep it in there, but absorb with the coefficients C1, C2 when you combine these two solutions. That's what I suggest.
so just a quick question. Normally when we create a new constant, you like us to explain what the constant is. But in this situation, if we just absorbed it and stated that as our constant, do we have to explain that our constant is a sub naught times a constant? Or can we just put the constant in there?
I suppose you could, it just doesn't look very pretty.
Okay. So you're fine though if we just go straight to just putting
I
the
can-
constant in, take it
I
out?
can see
All right.
Can you just explain maybe one more time
Please.
why you're taking out the first term of the first?
Because I think this pattern doesn't work. So you check this out, I'm being honest. If I were to replace 10 and 0 on the left-hand side, don't I get this, on the left-hand side? So before I start diving on the right-hand side, this better be where it's at. If not, I'm in trouble. So on the right-hand side, upstairs, I got a -1 and 0, that's perfectly fine, that's just 1. Don't look downstairs. I think over the right, I got my ace of naught. That's just fine. But notice how downstairs, the very largest factor is going to be described by this factor. And when I plug 0 in for n, don't I get that? But this implies that a sub naught is equal to negative a sub naught, or shall I say, they can't be the same. Do you see how the pattern fell apart with the very first value for n? That's why I had to kind of shave up, and this will happen a lot with for being
So-
in series. I shaved out the first term.
If you encounter like a logical contradiction, you just
Yes.
take it out?
Yes,
That's
I
it?
agree.
All right.
That's what you were saying.
So you guys, can we write our final solution?
Let's get that from over here. Screw this.
But you guys agree, all solutions are going to be of the form C1 times my 1 plus this sum. Plus C2 times x of 1 half times this sum. You guys happy?
You say that like we shouldn't.
Yeah.
I'm nervous about the C1 times 1 business going on.
I'm so not nervous about the C1 times 1.
Okay. And it must be the C2 business.
I'm good at real commitments right now. Say it. You, what, I didn't hear that.
Negative x times root.
Negative x over 2. Very nice.
I study markets.
Yep.
So in other words, you guys now are graduates of Math 31. You know what you need to know about math series. Wow, you guys, it took us an hour to answer one question. Kind of neat.
You don't need in y of 1 of x, you have an x to the n at the very end.
No, I've got SDNs everywhere, don't I? Like here and here. I agree.
Is variation of parameters as the differential equation? I guess we have functions of x. It should work, shouldn't it?
minimum, because the coefficients for y prime and y are really nasty when you force y double prime's coefficient to be 1, that wouldn't be too much fun, I think, with variation parameters.
The variation of parameters does work for,
Non-constant coefficient, yeah, it does. Michael?
I'm guessing it's a pattern, but for the last term, for the exponential to the, I guess negative x halves.
Michael, I skipped something, you wanna see it? By the Bradley,
Yeah.
when you're filming over here, do you remember what Katrina pointed out? She said I didn't have my NGA.
Yeah, I stood up and I filmed it again.
See, guys, can I take this last sum and just play with it for a minute? With that last sum, I think I got this. Negative 1 to the n, I'm just copying it down. I'm not doing anything down. Now, with this last sum, would you guys not agree that this n factorial seems to be kind of weird, just sitting out there like that? But I think the remaining 1, 2, 3 factors that stand all involve a factor of n. I'll pull it out. I got a negative 1 over a 2 times the next, or shall I say, this is sum of 1 over n factorial times negative x over 2 to the n. Or shall I say, this is sum of 1 over n factorial times question mark to the n, but doesn't that mean I've got nothing more than e to the question mark power? It's just a question mark power was negative x over 2, so I substitute it back in. Does that make you happier? Daniel?
So I have a question, like, when we make these assumptions at the beginning,
Yes.
how do we know that that's all of the forms? Is it when we solve it through, we'll eventually get all the forms from that summation? So how do we know
Let me
they're
put it this way. Number 1. If when you rewrite that dE in this form, if 0 occurs no more than once in this denominator, 0 occurs no more than twice in this denominator, factor. And the solutions to your additional equation differ by a non-integer, then this will necessarily be your solutions.
Like, even just yesterday's
Yes.
topics, when we chose just assume that y is equal to the sum of a and x to the n, what if there's another solution that doesn't fit that pattern? So it's not of the form, the sum a and x to the n. Or will all the solutions always fit that pattern?
I hate to use the word pattern. How about saying it this way? I'll be able to find a power series solution. What might not happen, and this is going to hurt Kern, your homework, what might not happen is that you might not be able to find a clean pattern. And so there are going to be sometimes I ask the question, oh, use Frobenius theory to solve this dE. It's just that don't give me the final answer fully. Just give me the first 3 terms. If the pattern, or excuse me, lack of pattern is so darn nasty, I might just ask you for the first few finite terms. I could do that, and I have done that. And hopefully I will do that in homework.
also, because of, I think it's randomly, since we do have 2 linearly independent solutions, we know for a fact that they can be used as the basis for all the other solutions.
Yes. Yes,
So
I agree.
everything else can.
You know you're going to have a vector space of dimension 2 that generates to this homogeneous dE. If we're not homogeneous, I'm in trouble, but I wouldn't go there, but with the homogeneous, definitely. You guys, I only went through one example. Can I not assign homework?
I'm okay with
Do you guys think you can just spectate me tomorrow? And I'll look at another example or two? Because I think there's a lot here, and I think the more exposed to it, the better off you're going to be. I will not slough off when I go home this week and write the final. This is going to be that important
This will be there.
on the final.
Are both Q and P going to be, non,
Analytic.
yeah, only use this theory, or is it possible that
Yeah.
one of them would be?
Quiz on that.
Or we'd have to use it?
No. It could be one
Quiz on
is
that, too.
analytic there. I'm just saying
On
that.
this?
On this part.
It just has to be done no more than
No.
once.
I'm not
X.
sure, yeah.
Yeah, 0.
I don't know if I can do a quiz this
This
weekend.
has
I
X
have
to back down,
to,
so
I have
it's
so
like
much studying I gotta do.
Then I will have more.
I don't even know how I'm gonna do this. Go home tonight and just get to work.
If we tried to do it this way, would we just get down, like, for one where they both are analytic, would you just get all of these?
I don't know.
Wouldn't it just be r equals 0, because then you have an x to the 0 out in front, and then x to the n by itself?
Yeah. It will indeed cycle you back to my technique for solving without an ordinary point. Okay, good question. I hadn't thought about that. Chris?
Why did we impose those constraints in the beginning about the amount of times the point was? Rather,
comes to the fact that it matches how many times you differentiate. It really comes into play with the differentiation process. Michael?
So, is this chapter ready for the book then?
Oh, I don't know, can I check? Officially, I've just started, or given an example of what you will see in section 9.4. So if you really wanted to, Michael, you could dive into this.
So can you assign homework for 9.4 and then just reassign it tomorrow?
I'm always happy to assign exercises.
Sure. Are we sure it's 9.4 or is this 9.5?
Well, I know your author entitles 9.5 convenience theory, but finding a serious solution about a regular singular point still is such.
Okay, okay.
And then 9.3.
So no, not yet. So 9.4.
Okay.
9.3 doesn't solve these. How about 9 through 16 all? Sorry for the evens, it just doesn't have that many exercises in it. So 9 through 16 all.
So are each of these problems like about an hour long? So this is
Well,
16-hour homework
When I
assignment?
do the class, I'm walking slow and explaining things. If I did this all night, it would take 5 minutes.
5 hours.
So maybe not 16 hours, like 13 hours or something.
7 hours.
Oh my God.
Okay, you guys, thanks for your patience. Oh, we finished early today. Oh, you guys, you're gonna miss this textbook in this class, aren't you?
Oh, I gotta keep the textbook.
Actually, you should. It's the best one I've found.
I don't ever get rid of my math textbooks. I got them all.
Yes, it's kind of nice that you don't have to buy the books, do you? Because you gotta